and then forgot to hit save.
Okay, thank you.
All right, so we are going to do these first two. We have log base 9 of x equals -1, and log base 12 of x is equal to 2. So you guys can go ahead and write those first two examples down, and then we're going to work through them. And I'll show you how we use this process to figure out what the variable is. And since these are all equations, on your homework and on this, you will have to write down every problem on your paper. So every problem is a star problem for this lesson. Y'all been lucky the past couple times and haven't had very many, but this time all of them are. So it'll take you a little bit longer for this assignment than for the last ones we had. Okay, so we've got log base 9 of x is equal to -1. Is the log part by itself? Yep, there's nothing in front of it. There's nothing at the end of it to get rid of. So in that case, we got the first step done. Now we're going to write this as a power. What's the base? 9, right? So we're going to go 9 to the -1 is equal to x. So 9 to the -1 is equal to x. Is x by itself? Yep. So 9 to the -1 is our answer, but it's probably not going to be written in that form. Actually, go ahead and figure out what 9 to the -1 is. It's 0.1111, and as a fraction, that is 1/9. So this is 1/9. Remember, a negative exponent tells it to go to the bottom. So 1 over 9 to the first. So our answer is 1/9. It could be in decimal form if you need it to be. Okay. All right, let's try out the second one. What's our base going to be on number 2? The base is 12, and we're going to raise it to the second, and that's going to equal x. So 12 to the second. Oh, sorry, I wrote x. Sorry, thinking one step ahead. Is x by itself? Yep, so let's just go ahead and evaluate 12 to the second. That's 144. And that's what x is. Questions on this kind where the log's already by itself? You okay? Thumbs up if that's all right with you guys, so if we can write it as an exponent and evaluate a power. Okay. All right, go ahead and write the next two examples down. All right, on these two problems, is the log part by itself? No, we've got to move something first, and then we do what we just did. So on our first one, we have to get rid of this 6 first, and it's 6 times log k. So we're going to divide both sides by 6. That was our step 1 to get rid of anything that's in the front of it. And I've got log k is equal to 2. That's 12 divided by 6. Okay. Now I'm going to write this as a power. What is the base if it just says log? It is 10, right? If it just says log, the base is 10. So you've got to insert that 10 in yourself. And now we write it as a power. So 10 to the second is equal to k. And we all know that 10 times 10 is 100. So our answer is 100. On number 4, we have a -8 in the front and -8 plus log. So to get rid of this -8, we are going to do what operation on both sides? Add. So we're going to add 8 to both sides. So log base 5 of x is going to equal 4. And now we do what we just did on all the others. 5 to the 4th is equal to x. I think that is 625. Does somebody agree? Yeah. Any questions on our first 4 problems? No? All right, go ahead and write the next 2 down. We're going to start to use our combining properties that we had from last time, our log properties. And these 2 are 2 different types of problems. We're going to solve them a little bit differently after we combine them together. So I wanted to show you one of each. Go ahead and write those down. Log base 5 of x plus log base 5 of 6 is equal to log base 5 of 66. And then log base 6 of 8 plus log base 6 of x is equal to 4. Okay, so on number 5, before I can think about writing it as a power or do anything else, I've got to combine these logarithms together. So when you're in log world, the plus between them means what are we going to do with the numbers after the log? If you have a plus between them, we're going to multiply them, right? That was from our quiz today. We did those. So this is going to be log base 5 of 6x. I'm just going to put the 6 first because it's going to look nicer. Equals log base 5 of 66. So all of the problems that we've done so far have had log equals a number, and we're able to write it as a power and solve it. This doesn't have log equals a number. It's got log equals another log. So if you're doing the log of something and it equals the log of something else, in your brain, you should automatically think, if I'm doing the log on both sides, the things that I'm taking the log of have to be the same. Does that make sense in your head? If you're doing the log of 6x and the log of 66 and they equal each other, then what we're taking the log of, they have to match. Okay? So if you have a log equals log problem, we can just drop the logs off and we set what's inside equal to each other. So 6x is going to equal 66. So if this side is going to equal 66, our whole thing is going to be the same because they would both had a log in the front. So we only do that if we have a log on both sides because you have the same operation. So what does x equal in this problem? X equals 11. Yeah. And you could plug 11 at the beginning and see. So if I did log base 5 of 11 plus log base 5 of 6, I would be doing 6 times 11. And that gives me the 66 that I need right there. Okay. Number 6 goes back to what we've done before, but I wanted to show you if you had a log equals log, you just drop those off. All right, on number 6, I have another plus sign. So that means I'm going to combine them together by multiplication. So log base 6 of 8x is going to equal 4. The log is by itself. There's nothing else in front or at the end. So now we're ready to write it as a power. So what is our base? The base is 6. It's raised to the 4th, and that equals 8x. So 6 to the 4th equals 8x. So you evaluate 6 to the 4th, and then we'll solve for x. So 6 to the 4th is 1,296. And if we want to get x by itself, what are we going to do to both sides? Divide by 8. And that's 162. Okay. So if you have two logs that need to be combined together, do that first before you either drop your logs if you've got them on both sides, or before you write it as a power if you have a number over there like we did on all the rest. You might occasionally sometimes have a minus. If it's a minus instead of a plus, you're going to have a division instead. So it would be like x over 8 or 8 over x, and then you would solve that part. So just make sure you do the right operation for that. Okay. Alrighty, next page. These are our last two log equations, and then we're going to go on to the exponential ones where we do it in reverse. I've got natural log of r is equal to 4. Is the log by itself? Yep, there's nothing in front that we need to move. What is the base when it says ln that we need to add on there? It is e. So if you see ln, we need to add the e for the base. Base e. We're now ready to write it as a power. E to the 4th is equal to r. A lot of times, they'll just leave it as e to the 4th. They won't actually evaluate it. But if the answer was a decimal option, you would do e in your calculator and raise it to the 4th. So that is 54.598. That's what e to the 4th is. But most of the time for this, I think I clicked on it where it leaves it in terms of e. On number 8, if negative 6 times natural log of n equals 12, is the log by itself? Nope. What do we need to get rid of? The negative 6, and we're going to divide, right? Because it's negative 6 times natural log. So natural log of n is equal to negative 2. What will our base be? E. So I'm going to go ahead and write that in there. Our base is e. Now, once you get to this part, we always do the same thing. We write it as a power. E to the negative 2 is equal to n. You might also see it written like this. Remember a negative exponent? This tells you to put it in the bottom of the fraction, so make sure you remember that. That could also be what the answer looks like. 1 over e squared. Or it could be in decimal form. The next kind are the exponential equations. So it's just the reverse. Instead of them giving us in logs and we write as exponents, these they'll give us exponents and we write as logs. If it's in exponential form, you want to get the base and the power by itself. So it just needs to be base to a power equals something. Then we're going to write it as a logarithm. Then we evaluate our logarithm doing change of base, like we had to do like that one on the quiz, log 32 over log 5. And then we solve for x if in case we need to do any extra steps after the fact. Most of the time it'll just be x equals, but there could be a number like some of the others that you had to do something after you were done. So when you write those steps down, go ahead and do write 9 and 10. You don't have to write this stuff in black if you don't want to solve each equation. You can just write down the problem. Let's see where the next one's from. Okay, not too bad. All right, so our first one, do we have a base and a power that's by itself? There's nothing else with it. Is it just a base and a power? Yep, so step 1 is done. So we're going to write this as a logarithm. So what is our base? On our first problem, our base is, anybody want to mouth it? Yeah, it's 20. So we're going to do log base 20 of 5 is equal to n. So log base 20 of 5 is equal to n. So I wrote this as a logarithm just like we've done before. I just switched it into log form. Now I'm going to evaluate this in my calculator, and that's going to tell me what n is. So remember, if I'm evaluating this log, I'm going to put log 5 divided by log 20, and that's how you put that in the calculator to evaluate. Or if no one's disabled your log feature in your calculator, some of them have a subscript area for you to write it. But if they don't, or you're doing it in Desmos, you need to do this. And that was 0.537. So on these problems, we combine together rewriting as logs, and we also combine together the change of base or the put it in the calculator. So those are the 2 skills that we have to know to be able to do these problems. All right, y'all go ahead and write number 10 as a logarithm. And then I'll double check, make sure that's good. So write number 10 as a logarithm. Okay, so did we have log base 10 of 68 is equal to x? Thumbs up if that's what you got when you wrote it as a log. Okay. Log base 10 is what the actual log button means in the calculator. So we could do log 68 over log 10 if we wanted to, or I can just hit log 68 because that's what that means. And this is going to be 1.833. So we do the same thing, log 68 over log 10 if you want, or just log 68 because the base 10 is the default base in the calculator. Questions on those 2?
Wait, I'm sorry, I didn't catch it. So I did it. 1 second, sorry. I did like the first one. So is that okay, or do I do it a different way?
Oh, the equation? Like you, or did you say
The
log 66?
calculator. Yeah.
Yeah, you can do that every time. It's fine. But this
Okay.
is base 10, and base 10 is what the calculator has for the default base. It's the same as just doing this. So if you didn't want to do the dividing, if it was base 10, you could just type that in, but it's not going to mess it up because log base 10 is just 1.
Okay. Thanks.
Mm-hmm. But if you just want to stick to that every time, there's not going to be a problem. You'll get them right every time. All right, now let's look at our next two. I think we only need to do one of these. Let's not do number 12 because it's the same. All right, number 11 is the base and power by itself. Nope. We need to add 5 first, and then we can do what we just did. So 18 to the b is equal to 16.6. And once you get to this point, you have to think, all right, now it's an exponent. I'm going to have to switch it to a log. So log base 18 of 16.6 is equal to b, and we put it in the calculator. That's 0.972. Questions on that if you've got a number added or subtracted at the end? It could be multiplied in the front as well. If it's multiplied in the front, you have to divide on both sides first. Okay. Questions on those where you have to do something first? Feel okay? All right, I think we have 1 or 2 left, and that's all. No, we have 2 more than that. 3, I think. Y'all good? I can turn the page? Okay. All right, we'll just do one of these. I think that's all we need to do on this one too. So here we have a base and a power. The power just happens to have something in it, so we'll have to deal with that in a minute. So this is a base and a power by itself. We don't have the big number in the front or at the end. So we have to now write this as a log. What's our base going to be? 16, yep. So log base 16 of 6 is equal to a plus 2. That's what our power is. So once we get our answer, a is not going to be by itself yet. We need to, after the fact, subtract 2 once we figure out what this is. So log 6 over log 16, get that answer, and then you need to subtract 2. I always just do this in one step in the calculator just because I don't like to have to do it again. You could, if you wanted to, figure this out first and then subtract 2 after the fact. But and a is equal to negative 1.354. So we did our log 6 over log 16, then we subtracted 2. Y'all see why we had to subtract 2? To get a by itself? You okay with that? Thumbs up if you're okay with the subtracting 2 at the end. Okay. The one that I erased, you would do the log, and then it would end up being k plus 4, so you'd have to subtract 4. All right, our last two, go ahead and write those down. We have e to the x is equal to 18, and 2e to the n is equal to 13. So e to the x equals 18, and 2e to the n is equal to 13. On number 15, do we have a base and a power by itself? Yep, so we're ready to write it as a log. What is the base? The base is e, okay? So log base e of 18 is equal to x. And if you put this in the calculator, log 18 divided by log e, you would get the right answer. But we also know that log base e is the same thing as ln. So remember, log base e is the same as natural log. So sometimes it's easier just to type that in. So log base e and ln are the same thing. So there's an ln button in your calculator as well. So ln of 18, it gives you the answer. So when you see log base e, we can replace it with ln. Occasionally, your answers will be left in ln form, like it might just say x equals natural log of 18, but otherwise it might be also in a decimal. (16) is similar, but what do we need to get rid of first on 16? The 2, yeah, it's 2 times, so we've got to divide by 2 first, because that 2 is not part of the base, there weren't parentheses. And 13 divided by 2 is 6.5. Now we have e to the n is equal to 6.5. Are we ready to write this as a log? Yep. So it'll be log base e of 6.5 is equal to n. And what is log base e the same as? Natural log, or ln. Natural log of 6.5 is equal to n. And we can evaluate that. So n is 1.872.